Hey, Lamar.
We've got Kevin, Lamar,
Hello.
Kent, Walter. We do have Walter, at least. We may not be able to get Walter's picture. I don't know. Are you still on mobile or are you online, Walter?
I can't get my video. I'm on mute on video.
Okay.
So if you can unmute me, you'll see my face.
Yeah.
I got it. Here we go.
Yeah. First started working on audio visual conferencing in my services group at Bell Labs in the mid 80s. We still haven't mastered it.
Well, we're doing better than the Golden Globes. I'll put that
out. What I like to do during this session is start off making it a Q&A with questions directed towards Walter, since we have Walter available, and we're very fortunate to do so. Walter and I have worked together for more decades than either of us will admit.
Me too, yes.
Had a few drinks afterwards, et cetera. So
for Stagg, that's a glass of milk, by the way.
Right. So let me just open it up for questions. If raise your hand and start speaking. So who? Kevin, I saw your hand. Did you want to ask a question?
Well, I was kind of curious if you know anything about Duke offering fiber. Have they said they're never going to do it, or like why don't they get into it?
When you say Duke, you mean
Duke Energy? I mean, like French Broad is doing it. Why doesn't Duke do it?
We had some experience when I was at the FCC with power companies. It really depends upon whether or not they think it fits within their business model. Also, broadband over power line was a bad meal for a lot of the companies because I think the technology was overpromised and didn't deliver.
Walter, if you can hear breaking up again.
Hopefully Walter will be back online. Kevin, let me address that a little bit.
Hear me now?
Yeah, we do. Yeah.
I just switched to cellular. Austin is having some problems here. I was saying it depends upon their business model. When we worked with a number of power companies when I was at the FCC, and the early introduction was BPL, and BPL didn't live up to its promises. And although to be fair to the engineers I was working with, there was a lot of skepticism about what it could do, especially in terms of evolvability. But
that's actually sending data over an electrical wire, like a
it's like DSL for commercial applications.
Is a separate wire going along the?
No, you send it over the power line.
Oh wow.
Okay. And a lot of companies got excited that they could get into the business, and it never lived up, and they withdrew. Some companies continue to pursue the fact that they could deliver fiber, but it really depends on what they think their business is. I'll give you one example of how business models change things. When I worked for Verizon, when we started cellular, we actually owned the cell towers. And at some point, the industry started realizing operating cell towers was like a real estate business. And the companies decided they weren't in the real estate business. So that was outsourced to companies that manage cell towers, which turned out to be, in the beginning at least, real estate companies. So I think it's predominantly a matter of what you see as your future business plan.
I just noticed as an aside that there's actually now some kind of a REIT for cell towers. You can actually invest in cell towers.
Yes. Well, again, it's an evolution of the industry. It's an evolution of the industry, but it just falls back to what the companies think their primary strength is, and where it ends up on a business case. Somebody presenting the management of the company, we're either going to make money or not on doing this, and that's the deciding factor. Yeah. If I'll make a prediction, if power companies start becoming a big force in doing this, Duke will change their mind.
Yeah, let me just add to that, Walter, because I actually did consulting for some of the largest the firm I was with, and I was in some of the meetings, did meet with some of the largest power companies. And Duke and others lost a lot of money trying to get into fiber during the dot-com bubble in the early 2000s, and they got burned. So then they all exited the market. And Walter's exactly right. The problem of your large power company is if you look at the incremental profit that you could make, given all the expense, and you look at your overall business, you don't move the needle. And so most power companies that are large, like Duke, have just decided they may partner and provide pole rights, but they're not going to get into it. Whereas for the co-ops, it makes tremendous sense. I mean, many kudos to what French Broad's doing. Haywood's partnering with Comporium and doing some good stuff, but the biggies I don't expect to change.
Let me add one other thing that Stagg and I talked about. It's when you start looking at other countries, especially countries that are not economic powerhouses, this cooperative sharing of infrastructure becomes much more of a viable business model. Somebody we used to work with, Vanu Bose, who's actually the son of the MIT professor who started Bose Speakers, was very innovative in terms of looking at cellular models for rural carriers. And he was actually moved his operations for a time to India because he found there the opportunities for sharing tower costs, sharing backhaul costs were much more available and made rural operations much easier. We're in the US with bigger companies dominating within their core competency, they tend to want to control a lot more. So you don't see as much of these, we'll all get together on a community basis and build a cell tower and it's available to all, or a cell site available to all. It's much more the key assets they tend to hold very close. And with an electric company, their key assets are not typically fiber. Their key assets are, are the infrastructure producing electricity. And we just haven't seen that developing as much.
Well, here in Texas, they don't even produce electricity anymore.
I've got 5 days of proof of that. Yes.
Yeah, I felt for you, Walter. A question from somebody else. They're just, I'm not sure. Anitra, is everybody? Oh, here's one from Hunter. Go ahead, Hunter. We can make sure Hunter's unmuted.
What a question.
I think Hunter's still on. Anitra, can you unmute Hunter?
He should be able to unmute himself.
Okay. Okay. I guess on this one, you can unmute yourself. So Hunter, you need to unmute yourself.
I think he also typed he does not have a question.
Oh, okay.
Well, let me expand on. I got interrupted by internet service.
Okay.
Let me. Somebody has a question. Let me expand on a thought I tried to develop in the last discussion. One, I think 5G will help a lot in terms of serving rural communities for a couple of reasons. One, it like 4G, it pulls in fiber, so you can't plan a 5G network without having a fiber base. So Stagg and I have talked that state and local plans ought to strategize on how you incent cellular carriers to deploy fiber. But the other two things that are associated with 5G, which make it interesting. One, it is forcing the development of microcells, which have a cost profile very similar to, say, a high-end router. About 10 years ago, the electronics for a cell site ran about $30,000. So if you wanted to put in a cell site to serve a local community, there was at least a minimum capital investment of $30,000, and then operational costs for the leasing the tower space and other things like that. By the nature of the beast, 5G really requires this low-cost microcell, The other thing that's happening is that the industry is focusing on how do you get away from requiring fiber at every microcell site. So they're looking at using what's called the V-band, which is about 40 to 75 gigahertz as a backhaul technology. So think of it as the fiber serves as an anchor point, and like an assault on a beachhead, you can then extend around that anchor point with these low-end cell sites that basically use wireless technology and probably about 10 gigabits of minimum 10 gigabits of capacity to extend that. And the other thing that makes 5G a very nice technology is it is totally dependent upon directional antennas, which means it fits in very easily with a model of supporting a wired service to a fixed location, if that's what your desire is.
Walter,
So-
I'd actually like
ahead.
to kind of counter that.
Go ahead.
I find 5G as a solution looking for a problem. I don't see microcells happening in the mountains. I just don't see that happening. We use V-band all the time. We use it quite a bit, 60 gigahertz, 80 gigahertz and the like. 60 gigahertz is usable to a kilometer at best, line of sight only.
Correct. I said extending, and I think it depends. It depends upon two things. It depends upon a 5G deployment plan that's within a local area. And then in terms of accessing that, whether or not you're within proximity. I'd say proximity would be maybe 1 or 2, maybe 3 hops. So maybe a maximum of 3 kilometers around the initial sites, and whether or not you're close to utility poles. If you can follow up to 3 kilometers, you can follow utility poles line of sight. So, and again, I'm not offering it as a panacea. It doesn't solve, there's no single technology that will serve everybody. Okay,
Yeah.
But 5G reduces the cost profile for deploying cellular service, and cellular service already has a fairly sizable footprint in the United States for population served. So it gets you another 2, 3, maybe 4%, whatever you want to start with in terms of baseline. But it does give a dimension. And then I said in the final last resort is always going to be satellite. And the exciting news there, if it works, and I say if it works because not all the companies proposing the service are going to succeed, but the LEOs offer for the first time to the unserved population terrestrial performance. You can get 100 megabits, but there the limitation is capacity. There's no real way to expand the capacity as a major service. And I was quoting Elon Musk before. Elon Musk himself basically admits that, or states that the service will at best serve 3 to 4% of the population.
Yeah, well, Walter, I'd like to jump in here too on the comments about 5G. I mean, I totally agree with Walter that, it has important niches for fixed wireless, and it very much depends on line of sight. At those frequencies, you've got to have very clean line of sight. In fact, I actually designed to help cost out and design a system from New York to Chicago at those high frequencies. And if the towers moved too much, you had a problem in the wind. That was for a very high willingness to pay market called high frequency trading. But 5G is very important for 2 reasons, and Walter made that in his talk. One is it has a niche in fixed wireless, but a small niche probably, and there are other niches. What 5G, as Walter said, is going to be a game changer for new applications once you get enough 5G, and this is where we have to be so alert in Western North Carolina, because the people developing the new applications for 5G that rely on the low latency that you cannot get with 1G, 2G, 3G, or 4G, all they're looking at is the total market size. So once you have 5G deployed to several tens of millions in the US or hundreds of millions around the world in urban areas, there are going to be new applications that take advantage of that. That's a virtuous cycle that we've seen for 30 or 40 years, where as soon as you get a higher performance networking possibility, applications get developed. So once there's a critical global market for 5G applications, and there'll be Internet of Things we haven't dreamed of, et cetera, then if we don't have 5G networks here, either low band or high band, we're not going to be able to participate in those new applications. So we got to work to accelerate the introduction of the advanced cellular networks. At the same time, we have to solve our fixed broadband access.
Stagg, what do you see as an application that might run over 5G?
Walter, why don't you take the first?
Well, it's the first. Understand, when people talk about 5G, and it almost irritates me, is they focus on speed. And frankly, aside from video streaming, we've actually I've had roundtable discussions on this subject. I've had the opportunity to sit down. The FCC used to run something called the Technological Advisory Committee. So, and they send their leading companies, so Google, AT&T, Verizon, other companies will send their best and brightest engineers as to represent themselves to the FCC. One of the questions we asked is, what do you do with all the bandwidth? And the consensus was, at least for the foreseeable future, nobody could come up with a need for that speed unless you were focusing on entertainment video. Now that'll change, and people recognize. So I'm saying the near-term view is we don't need the bandwidth. Okay. On the other hand, it's the first technology that's been developed. Almost, the 4G had a little bit of this, but it's the first technology that's been developed to support telemetry operations. And what you need to do that is a different type of protocol. You need to use battery saving. You have to recognize that some of these operations are battery driven, so you have to be very sensitive to battery life. That was not taken into consideration in any previous generation. Okay, the things that are being looked at, vehicular communications, enterprise applications, metering applications, can all be done on 5G. It's not going to happen overnight. Okay, but there's a growing market, not only with 5G, but low power telemetry networks are being built today, recognizing that there's a growing market for machine to machine applications. And it's actually increasing at about double the rate of human applications right now. So the industry sees that by adjusting the technology, and this has been a decade in planning, they can start supporting this wide area network capability that supports gathering data from vehicles, fleet operations, home operations. One of the largest applications currently for machine to machine applications is found in the home, because the devices that people have in the home, 15 to 30 devices in some homes now that require communication with other parts, with other elements across the network. So it's still very nascent, but again, the growth rate is significantly higher than just about any other application. And it's viewed as one of the futures of the capability. One other thing I wanted to point out, there was a famous study done years ago when the Bell system was broken up. And they looked at a lot of different strategies for how AT&T, for example, could get into the local business. Okay, and what they discovered was that a beachhead strategy seemed to work the best. What they rapidly uncovered, and it's obvious in hindsight, was that if you can extend a network to a key anchor point, an anchor tenant, then you have a secondary opportunity to serve the surrounding area. And I would say for both the fiber deployment and 5G deployment, that principle still holds, that if you can figure out a way to pull fiber closer or to a point, bring 5G into an area because of a specific need or application, you create secondary opportunities where you can serve other elements of the population. It's getting the anchor tenant identified and serviced. And I think that's what rural needs to be looking at, is how they get these, not how you serve an entire population perhaps, but how you extend the infrastructure a kilometer further, 2 kilometers further into a territory. Because if you can do that economically, okay, then in the second pass, okay, you've lowered the cost for serving the surrounding area. That's what I find interesting about 5G. That's what I think a strategy is in terms of fiber, is that you got to bring it in, a kilometer at a time, and you drop the cost then for serving the rest of the area. And the way the electronic costs are going, the ability to extend it, especially with 5G, are coming way down.
Yeah, let me give 3 specific examples. Well, 4. First of all, I'll give you the one that I think is not the 5G application. We do call it the true killer application, and that's watching high-speed streaming video while you're driving. So let's hope that's not, not what happens. 3 applications that I think 5G will enable. One is whole new and better EMT services. So maybe it's the broader family is telemedicine. So, you know, when an EMT is out at a site, they can provide the same type of service telemetry or high speed, not just high speed, but 5G based services that you'd see within a hospital using a very sophisticated Wi-Fi network. A second is the basically, if you like drones, they may not even be up in the air, but lots of farming applications where you'll have automated equipment out there taking in all sorts of visual and other information from sophisticated sensors, you know, and mowing the fields for you or doing whatever. So there are a lot of very sophisticated, you know, agriculture has gotten very sophisticated, as people who know a lot more than I do. And 5G is going to enable a whole new set of those type of automated applications in our forest and our lands, et cetera, et cetera.
Well,
And
seriously,
then,
these are all low data rate needs.
well, you've got several things. Some are low data rate, some aren't. As soon as you start taking in visual information, you know, yes, GPS based, where you're only looking at lat longs, is low bandwidth, but there's also the low latency. There are things that you can do when you have latencies of a few tens of milliseconds or less that you cannot do when you have latencies of 100 milliseconds or more.
Yeah,
So
that's a good. I just wanted to point out. Let me just point out that the average latency across a 4G network, and a 4G network was designed to be lower latency than a 3G network, but the average latency is somewhere around 80 to 100 milliseconds.
Yeah.
Okay, and 5G is talking about 10 milliseconds, 1 millisecond latencies, depending upon a number of factors. I'll leave it at that. So and the thing I said earlier was that there's too much emphasis, I believe, on speed associated with 5G. You got to recognize 5G is a fundamental re-architecting of the whole cellular network. It's a software-based network, which means that it's much more flexible and agile. It's much more like a cloud service. 4G was a hardware-dependent network. It was built to do basically one primary service, and the hardware was designed to support that. It's not very flexible or scalable. It's not adaptable. If you're going to change the innards of a 4G network, and then change the capacities or service capabilities, that's an expensive road because it's hardware dependent. 5G is being built on common PC platforms, software based. You can spin up a different application because the platform is common across the network. And for the first time, it's brought in protocols and capabilities that support the specific communication needs of machines as opposed to people.
Yeah, and that leads to my third application, which is it's the things that you can do within a building with a very sophisticated, high speed, low latency, you know, cloud-based or edge-based network will extend into the mobile world. So it's the things we don't know about, but once you get a critical mass around the world, will be out there. And I'll give you one good example of how bad we are at forecasting that. A company that will go unnamed, that Walter knows I did a lot of work with, did a study for the company Walter and I worked for, AT&T, working closely with Bell Labs in the early 80s. And they forecasted the cellular market for the year 2000, and they forecasted 800,000 people in the US would have used cellular telephones in the year 2000. And they were instructed to be as bold as possible and to work closely with the Bell Labs engineers. Now that firm blames Bell Labs for that forecast. By the way, the actual answer was 80 million. So the forecast was off by 2 orders of magnitude on the low side. And as a result, AT&T agreed to give the cellular companies local telephone operating companies. So AT&T lost many, many billions of dollars on that decision. That company blamed Bell Labs because Bell Labs said the one thing they could not imagine in the year 2000 was small handheld phones. In other words, cell phones in the early 80s needed to be powered by a battery that you would carry in a backpack or in your car. And Walter and I probably both had cell phones that were mounted in the center of our car running off our car battery. So, what I'm saying there is I don't think we know and can imagine all the machine to machine and other applications. But if Western North Carolina doesn't have 5G widely deployed, we will be left behind and we'll be on the wrong side of the mobile digital divide.
I mean, it's all great talking about all this
Yeah.
5G stuff, but I'll tell you what, there's people out there with DSL that would kill for just a 25 megabit connection. And it's grand talking about the 5G, but we got a bigger problem in front of us other than getting 5G to people, that this quote unquote low latency service talking to machines. How about we talk about people and these people need connectivity? Is that what we're talking about here?
Yeah, no, I agree. We have to solve our fixed access problem to homes and businesses also. But I go back to Walter's point. Both of those need deep fiber. So if we get deep fiber out there to solve our fixed needs, and off of that deep fiber network is fixed wireless access to the home or business, hybrid fiber coax, or fiber to the home, not DSL. Maybe we should let Walter speak about the status of DSL technology, but wireless tails, coax tails, fiber tails with a deep fiber infrastructure enables that fixed wireless future that is our highest priority. Totally agree there. And also enables our mobile future.
Let me add something else. I said before, you need a beachhead strategy. Okay? One of the ways you get critical economics is by combining applications. The tendency in the past, and a lot has had to do with the efficiency of hardware versus software, and that has shifted over the decades, but is to build specialized networks. At one time, you had a voice network that did one thing. It handled a 3 kilohertz audio voice call. Okay, by combining applications, you lower aggregate cost. And we see this right now, for example, and I'm going to be very biased in my opinion. Right now, for example, there's a proposal from the Department of Transportation for using a dedicated highway transportation network, communication network, which will do one thing. It will allow cars to communicate with each other. Okay, if you can combine that application with, say, 5G, now you've got 2 applications supported with the same investment of infrastructure. So in that sense, to the extent that there's an enterprise application for 5G, that there's telemetry applications for 5G or for fiber, and you can combine those all together, you drop the cost of deployment and you increase deployment. So none of what we're saying, and in fairness to the last questioner, there's nothing you can do for tomorrow other than what you have today. So if you're looking for the immediate solution for somebody's problem of DSL, it doesn't exist. The solutions we're talking about are going to take years we're talking about a decade of change. But if you really want to keep up with the times, if you want to ensure a digital divide doesn't develop, you're going to need a long-term plan. And that long-term plan at some point becomes a short-term plan because you've evolved into it. So I don't deny the problems that you have serving the immediate community. But again, what our experience at the FCC, when I was still at the FCC, was that we were just wasting our money supporting, in effect, lifeline-like services or subsidizing the service itself because it never went away. 5 years later, the service that we subsidized was now obsolete and we'd have to come up with another mechanism. It's making sure you've got the infrastructure. And Paul Desad did a much better job talking about that. But it's ensuring you've got an infrastructure plan, which is going to get you out of the hole you're in into a more viable environment. Up until then, you've got to live with the current solutions to the extent that they solve your needs. LEO is going to be very important, especially, again, if you don't have service alternatives. But at some point, LEO, the low Earth orbit satellite solution, tops out in terms of capacity. And we've seen this with other satellite services. I can sell you 100 gigabits per second. I might not be able to deliver it because everybody else has the same commitment and same promise. So at some point, you top out with the capacity. And I see no way, and Elon Musk sees no way to increase his capacity beyond a certain level. There's only so much radio spectrum that you can use.
Excuse me, Stagg, Walter.
Yes.
I just want to let you know that we've been having a slight chat issue where some people aren't able to chat. So I just wanted to open up the discussion. So if anyone wanted to say any questions, this is your time to. That's all. And also, we have about 13 more minutes.
Okay. So I'll try to be quiet. Go ahead.
One quick question. Thanks, Anitra. Yeah, we can't chat for some reason, it's disabled. But on the 5G question, Walter and Stagg, is that sub-6 as well as the higher gigahertz, everything you're talking about in terms of the capabilities and the promise of 5G?
When you say restate your question, when you say sub, you mean sub-6?
Are we talking about sub-6 as well as everything over 6 gigahertz?
Yeah, in fact, that's my basic point. It's the main. I've lived through all generations of technology, other than maybe 1G, which I got my first cellular phone call in 1976 when it was still not yet a service. A friend of mine on the project at Bell Laboratories called me and said, "Guess where I'm talking from?" Okay. But it's a major re-architecting. T-Mobile is deploying a 5G network at predominantly 2.5 gigahertz. They've got some other frequencies built in there too, but it is a reworking of the technology. It's and at 2.5 gigahertz, it's not going to offer you much more speed than 4G. But again, if you're not interested in video streaming, you don't need the bandwidth. Now, there may be some point. I'm communicating over my cell phone right now, and I guess I'm using maybe a couple of megahertz of a couple of megabits per second of bandwidth. In 2023, Cisco's predicting that 63% of the televisions in the household will be 4K. You can go out and buy an 8K. At some point, I'm guessing this Zoom will be a 4K conversation. Not now. So at some point, speed will be important, but it's being made available at the mid bands too. And it is a major, unless you're in the standards work, you can't imagine how much a reworking of everything 5G becomes.
I've seen a couple of chat questions. One of them says Skyrunner in Transylvania County has a TV tower up at 5,000 feet. And so the question is, barring cost, what's the top end range bandwidth providing service to the residents if they've got a tower that high? And I think probably the answer needs to be with or without clean line of sight, because that makes a tremendous difference.
It's also how much bandwidth are you providing, because it drops off enormously with distance.
Yeah.
Well, at elevations like that, that's almost too high, because you start hearing everything and you get the signal to noise ratio that drops immensely. So you do a lot of down tilt with the antennas.
Right.
We've been able to do 10 miles out plus 200 megs.
They do actually further in the West. We had some experience in the Western states, and that was eye-opening for me. They actually do double that. But again, it's where they have more cows than people.
Yeah, we have things called RAIN. By the way, we have on the call Lamar Owen, who's the chief technologist at Perry, which is the Piz Gastronomical Research Institute, and at one time had the largest radio telescope in the world. So if you get a chance to visit that. But Lamar's another resource I'd like to point out, particularly on, satellite technology and rain fade and all that. Let's see. Yeah, and I guess, Walter, that was another question. People were asking about what's the effect of rain fade when you start using these higher frequencies?
It depends on what distance you're going, okay? And yeah, at shorter distances, not much impairment, but if you're looking to, especially as you get up into the millimeter wave, you start seeing impairments. So at the 30 gigahertz, which is what's called the KA band, it's actually not too bad. And we've seen some, in fact, we have some stats from satellite data that show that it takes a real downpour to wipe out the service. But certainly when you get up into the V band, rain fade becomes a much more tenacious issue. But again, you're transmitting that, therefore, you can always take it into account into your power margin. So the issue becomes, how far can you go before rain fade becomes a significant service problem? That's engineerable, but typically means shorter distances in areas with high rain, longer distances in areas where you don't have as much rain. It's manageable.
I'm sorry. We've got 60 gigahertz links and 80 gigahertz links. Right. 60 gigahertz is the most affected by humidity and rain, and typically the radios have a 5 gigahertz failover. A kilometer at 60 gigahertz, 2.5 gig of bandwidth. 80 gigahertz is much better, can do a couple of kilometers, do 10 gigabits, excuse me.
Thank you. Yeah, the engineers take it into account, but it does impair it does impair the economics of the service.
Yeah, I've observed so many of these, the viability, and that's why we need all the different players here, gets down to not the technology, but what I call the civil engineering or the political engineering, permitting. And good example of civil engineering is I'm looking right now at a beautiful tower on top of Mount Pisgah that Skyrunner could provide great service into our valley. But they're not that interested because they've got better opportunities. And the reason is they took out the inclined railway to serve that tower about 10 or 15 years ago for safety reasons. So everything that needs service has to go up there in a backpack. And I've hiked up to the top of that. And you don't want to be hiking up there with a heavy backpack up. There's rock scramble to the top of Mount Pisgah. So, it's one of those realities. The people in our valley who can see another Skyrunner tower that they've got good access to can get good Skyrunner service, and the people who happen to be on the wrong side of the ridge lines can't.
But let me add something else too. Vanu Bose, who I mentioned earlier, I had a lot of respect for, unfortunately died very young, developed low-cost cellular equipment. He did a trial in Vermont. He found out that his biggest cost expense in Vermont were the regulatory fees associated with cell sites. And what he found, at least in Vermont, was that the regulators viewed each presence as a cell site. So he found that his biggest hurdle in economics was the fees, which regulators sometimes feel are revenue streams. But one of the things the community should look at is if they want broadband, whether the regulatory structure supports that deployment or hinders that deployment. And that's a decision communities have to make on a community by community basis. If you tower permitting processes, the speed of permitting all add to cost. So another thing I throw into the pot is if you're going to develop a plan, align it with your regulatory structure to ensure that the regulatory structure supports the plan.
And that, as Walter said, that's both a local and a state and a federal issue. And that was actually part of the National Broadband Plan, had some chapters on all the things to lower the cost of permitting and building and construction. And unfortunately, probably got the least amount of attention in terms of implementation.
And by the way, this is still an area for study. I'll point out Google, which innovated with, if they wanted your Google Fiber, you had to give them the capability to do efficient scheduling. So one of the things Google said, if we're going to go into a community, we can't do it a street at a time. You have to work with us to allowing us to put the fiber in and drop the, in one fell swoop. You have to make sure that we're not impeded, and certain communities agreed to that, some didn't. But that was one attempt they looked at, and it was partly successful. There's some issues with it in terms of dropping the cost of fiber deployment. What are the right factors? I don't think anybody really knows yet, but things that need to be considered maybe are flexibility, working with the providers and making sure they have the lowest cost for deployment.
Probably why Google went to a hybrid situation.
Yes, it's fiber to the home is costly, and they found that more costly than they expected, even with their innovations, and they tried a lot of different things. In fact, that's something you might want to get at some point somebody from Google to talk about the cost of deployment and things that they found from their experience. It'd be an interesting discussion.
One of our, matter of fact, one of our managers is a Google Fiber deployment manager, or was. So we kind of keep our eye exactly on how they deployed that.
And by the way, I should mention the most important part of the National Broadband Plan that Walter and I were involved with in 2009, 2010 was never written down in the broadband plan. And that was the real purpose of Google Fiber, because Google Fiber got rolled out into maybe 10 cities or so with lots of hoopla. Google and the FCC and all knew that Google really didn't want to be in the national fiber business as a major service provider. The main purpose of that was to scare the devil out of the telcos and cable companies who were no longer upgrading to, they were going to cap out speeds at the megabits per second. And so since the Telecom Act says got to use competition, there were lots of quiet discussions that got Google to go into the market to signal to the industry the telcos and cables didn't move. Google would move aggressively.
Stagg,
the credit to cable companies, they did upgrade their networks. Unfortunately, our telcos did not in general.
You got 30 seconds to wrap up according to mine.
Okay. Well, thank all of you. My email address is lsnewmanjr@yahoo.com. Please do, if you want to follow up with questions, and I can get to Walter and we can get answers back to you. And I thank all of you for participating. Nitra, any other logistics? I guess we're now going to go back to the main session. Is that correct?
Yes, we are about to go back to the main session. Thank you, Walter. Thank you, Stagg, for having this dialogue, and thank you everyone for participating. And even though there were technical difficulties, thank you guys for coming.
Thanks.
Hey everyone, welcome back. That was good for you guys. Bill, you want to help us out?
Thanks to everybody for hanging in here. When we designed this program, if you recall, when we did the last summit at noon, we kind of stopped and said, stay around and have lunch and meet with various people to chat. So that was the format. And to have as many people hang in there for this long, I'm very impressed with your commitment, and you all deserve some sort of prize for doing that. We're going to have a quick report from each of the four groups and then a wrap up. And so let's start first with Arthur Solito, talk about funding. I don't see Arthur signing on. Will we switch to Greg?
Okay, I'm here.
Oh, there you are, Arthur.
I was prevented from unmuting myself. I talk too much, apparently. So in our session, we talked about grants from the FCC, the great grants, ARC partnerships between the HHS and rural health, the internet office, and a couple of things to note. Comporium down in Transylvania County was recently announced a grant award to help with broadband implementation there. Let's see, we also mentioned Charter's commitment to following through on RDEF funds, and I believe it was Mike Tank from Charter who mentioned that in addition to the public funding that they're getting, they're also putting a lot of private funds into these projects, so we're grateful for that. And we ended with David Brown, I believe, thanking Bill Cedarberg for his dogged relentlessness in keeping this all going, which is totally true. And grateful for Bill. So I'm sure I missed a bunch, but that was
an excellent report. Although it wasn't Dave, it was Matt Pearsall who was commenting on that. So, but thanks for the thought anyway. Greg Vogt, on talking about with Paul, continue that conversation.
Right. In the federal policy group, Paul, thank you very much for joining that group where we had more in-depth conversation about federal policy. And we talked about the need for more competition from municipal organizations involved in order to make sure pricing was lower. We also talked about the difficulty with pole attachment regulation and how it was very expensive for certain providers to get on existing poles, and that there was more work that needed to be done in that area. And finally, there was a strong statement that there needs to be more block grants to states to allow states to fund their own programs. In fact, it was a model that the FCC itself used in New York State that was very successful in building out broadband in New York. And that's what we talked about.
Great. Sounds good. And Stagg Newman with Walter Johnston. Stagg. Stagg must have gone to feed his horses or something.
We're unmuting him, Bill.
Okay. I enjoy giving Stagg a hard time, so this is delightful. So unmute Stagg.
Okay. Yeah, first I'd like to thank Walter. We mainly took advantage of Walter's technical expertise to answer a lot of questions. I think I'd summarize the technology this way: is we need an all of the above solution because of the high cost in our mountains, because of our granite and our rocks and our beautiful hills and all. So we need deep fiber, and then people need high-speed tails, and those can be fiber to the curb by companies like River Street, French Broad Electric, AT&T, or Comporium. Can also be the hybrid fiber coax networks by companies like Spectrum, Charter, Morris. Also, I think Comporium has some high speed. And wireless has a very important role to play because some places we just don't have the fixed wired infrastructure. And that's a Skyrunner or an Open Broadband. There are quite a few other wireless providers in the further western counties that I won't try to name all of them. And cellular has a good role to play, but you really only get the superior cellular performance if you're really close to a cell site. So that means, again, more deep fiber, more cell sites. And the way we solve these problems is working together to aggregate demand and come up with enough funding to close the business case. And a lot of that cost is unfortunately not to do with technology. It's the civil engineering and permitting and just the nitty-gritty hard stuff.
Thank you, Stagg. And now to Jeff McDarris, school superintendent down in Transylvania County, also a partner with us on the My Future NC, and an impressive guy. So Jeff, I haven't talked to you before on this, but welcome and thanks for doing this. Did your group break apart with fistfights on the virtual world or something?
Well, we're celebrating Dr. Seuss here today, but let me give you some rapid fire takeaways from our meeting, which was great. First of all, very impressive. Educators, so many individuals we turned on a dime, quite frankly, and were able to put out some ability to do remote learning pretty quickly. Partnerships are incredibly important. This has made us all more tech savvy. It was a monumental effort and continues to be to provide accessibility to some families in areas that are not that far off the beaten path, but they just cannot get a signal to them. There are some places that just cannot be reached. We need more broadband than you think. My takeaway on that would be like the Atlanta interstate system years ago when I would go down and watch the Braves. When they built 2 lanes, they realized they needed 4. And I think that we're finding that out increasingly from the conversations that, especially in households where you have multiple students and parents that need to be on at the same time. Professional development is critical, cannot be overlooked. Certainly laptops versus desktops. Cybersecurity is something that everyone needs to be thinking about as we broaden our base out there. And we cannot overlook the importance of social emotional contacts with people as they are somewhat out on an island. But I will close by saying the creativity out there is heightened and it's actually very enriching. And I think really the sky's, there's no limit. Thank you.
Thank you, Jeff. Unbelievable that we're kind of right on schedule, but I noticed that Mark Hoyt signed on, and Mark was with us at the very beginning of this whole process. Mark, I'm going to ask you for a 1-minute summary of what you heard and any quick thoughts. We need to unmute Mark. Well, so much for Mark's quick thoughts.
There we go.
Oh, there we go. Okay, Mark.
Sorry about that. I didn't realize it was locked. Sarah, you locked me out. So I'm impressed at the diversity and the breadth that this group and collaboration has gotten to. I remember a much smaller group when we started, mostly city and county folks, and now it's including a huge, enormous group, and it seems to be making great progress. I want to thank Sarah for her comment about it's not just connectivity anymore. I know there are people not connected. I understand the problems, but there are so many more people that have connectivity and don't know how to use the technology, don't have the education, don't have the pieces that make it useful and make them be able to join the rest of society and do those kind of things. So please focus on that as your next step and help people understand how to use the technology, and then help us behind the scenes get the stuff ready so everybody can keep connecting and getting your work done.
Great. Thank you, Mark. And finally, when we organized all this, we were really impressed with comments that Sarah Thompson made. She's done a great job leading the Southwest Commission. And Sarah, why don't you wrap it all up for us and send us on our way?
Sure. Thanks, everyone. The Planning Committee thought maybe we should end this with a call to action, so I'll do my best. This is a regional issue, and Sarah Nichols' organization, Nathan Ramsey with Land to Sky Regional Council, and us with the Southwestern Commission Councils of Government are regional planning organizations. So continue to work with us. We've been working on this issue for years now. Let's work together on this. We've done a ton of planning and mapping, and we're currently promoting the heck out of the state survey so we can get some more accurate maps. Also, continue to organize locally, work with your providers, befriend all the experts that are on today's call. Let's keep them in our region helping us move this issue. The broadband landscape is constantly shifting and is going to continue to do so. It's a regional, statewide, national issue that's going to be solved and advanced at the community level. So the solution in one community may not mirror the solution in a neighboring community, and there's a lot of variables at play here. let's continue to advocate, educate your stakeholders, encourage them to advocate. Are there funding programs that aren't working? Let's figure out how to get them to work better. Are the FCC maps faulty? Let's fix them. Should we be seeing federal funds passed down as block grants? Let's advocate for that. And, you know, throughout this call this morning, I've been thinking that maybe we need a stronger, more organization around advocacy on this issue in Western North Carolina. And I think the COGS could really help with that. So thank you all for your continued perseverance on this incredibly important issue. We're living in very interesting times. Technology is changing rapidly, and the future of our rural communities especially are sure to be brighter if we get high-speed broadband out there. Thank you.
Thank you, Sarah. And now it comes just a quick thanks for Sarah Nichols, who worked so hard on this. And Sarah does a great job with Land of Sky. We have a couple students from UNCA, Anitra Griffin and Elias Landsman, who have helped put this all together. Paul Moon, also from Land of Sky. Thanks, Paul, for your work. Mark Zarnecki with the website and on the technology side. Thanks to everybody that has participated on this. And I know a lot of you would just like to keep talking broadband, but I'm hungry for lunch and I want to go and end this. So thanks to everybody, and we'll be in touch. You've got some great written material that we've sent you. Be sure to read that and get it all printed out and distributed all around your neighborhood. So with that, have a great day. And Chancellor Brown, is it okay that we sign off now? I see you're still with us. Keep those catamounts working hard down there. Okay. Bye-bye, y'all.
Bye.